Have you ever wondered what would happen if one day all those massive electric vehicle charging stations, thousands of charging posts stretching from California to New York, from Houston to Chicago, suddenly became useless overnight? Not because electric cars were banned, not because batteries became obsolete, but because someone had just proven that you no longer needed them, and that someone was not a Silicon Valley startup, not a sharp-tongued tech billionaire making noise on social media. It was a 75-year-old Japanese company known for being cautious, disciplined, and so quiet that it almost feels frustrating. Honda Motor Company. On an unannounced afternoon, with no red carpet and no flashy presentation, Honda's CEO walked into a sealed laboratory in Tochigi Prefecture, Japan. Inside that room, there was only one vehicle. No charging port, no power cable, no lithium battery pack at all. Just a new generation hybrid engine, and it generated its own electricity while running. 48 hours after the information leaked, $17 billion in market value vanished from electric vehicle stocks. Tesla staggered, Rivian plunged, Panasonic turned red on the trading board, and Wall Street, which had bet trillions of dollars on the future of electrification, suddenly was not sure about anything anymore. So what really happened inside that sealed room? How does this technology work, and why did it make an entire trillion-dollar industry tremble? Is this truly a turning point in automotive history, or just a strategic bluff from a giant trying to reclaim its position? And more importantly, if this technology is real, what does it mean for you, for the car you are driving, and for the energy future the whole world is trying to build? Before we dive deeper into the story, if you enjoy deep analysis videos like this, not shallow, not cheap clickbait, hit the subscribe button now so you do not miss the next episodes. The world bet everything on electric cars, and that is the problem. To understand why the leak from Tochigi caused such a shockwave, we need to stop for a moment and look at the bigger picture. How the global auto industry placed its bet on electric vehicles, and why that bet is far from small. Over the past decade, electric vehicles have not just been a technology choice, they've become a political statement, a climate commitment, almost an ideology. The United States government poured hundreds of billions of dollars into charging infrastructure through the Bipartisan Infrastructure Law. The European Union announced that it would completely ban gasoline-powered cars by 2035. Dozens of American states set similar targets, and automakers from GM to Ford, from Volkswagen to Hyundai, announced plans to electrify their entire production lines at a cost of hundreds of billions of dollars. But beneath that shiny surface, cracks have been growing, and very few people want to talk about them. First, there is the charging infrastructure problem. In theory, America's charging network is expanding. In reality, tens of thousands of public chargers are regularly reported as broken, overloaded, or simply not enough. A 2023 study in California found that nearly 1/4 of the surveyed direct current fast chargers were not working properly. And in rural areas, which make up most of America's land area, the distance between charging stations remains a harsh reality. Second, there's pressure on the power grid. When millions of electric vehicles plug in at the same time in the evening, the grid faces a burden it was never designed to handle. In Texas, California, or Arizona, hot summers have already pushed power grids close to the edge. Add millions more electric cars into that equation, and the problem becomes far more complicated. Third, there is the lithium supply chain. Electric vehicle batteries need lithium, cobalt, nickel, and manganese, much of which is mined in Congo, Chile, Argentina, and China. These mines come with uncomfortable questions about the environment, child labor, and geopolitical dependence that no country really wants to admit publicly. And this is exactly the context Honda saw long before the rest of the world started to realize it. But to understand why what Honda has just done matters so much, we need to look at the heart of the entire story. What exactly is the machine inside that vehicle? Project HX Prime, Honda's 17-year secret. In 2008, while the whole world was getting excited about the promise of lithium-ion batteries and the first modern electric vehicles were beginning to appear, Honda quietly launched a secret research project at its research and development facility in Tochigi Prefecture. They called it Project HX Prime. The central idea behind the project was not to build a better electric car, it was to build a system that did not need the power grid to survive. Honda's engineers saw a massive blind spot in the electric vehicle revolution that was beginning to form: total dependence on outside infrastructure. Electric cars need charging stations. Charging stations need the power grid. The power grid needs power plants. And that whole chain can get clogged, disrupted, and, most importantly, it does not fit most of the world's population who do not live in major cities with enough infrastructure. So what if you could build a car that created electricity for itself while it was moving? That was the question Project HX Prime asked, and according to what leaked, Honda found the answer. By 2012, the project already had working prototypes. But then everything suddenly disappeared. No press release, no official cancellation ceremony, no explanation. Project HX Prime simply stopped existing on official paperwork. Insiders revealed that it was not a technical failure that killed the project. It was political and economic pressure from several sides. Major oil companies, rising electric vehicle startups, and even Honda's own battery supply partners, none of them wanted to see a technology that could disrupt the ecosystem they were building. On top of that, Honda at the time was under pressure to focus on the Clarity fuel cell, a hydrogen-powered vehicle, a direction considered more politically safe because it did not directly threaten anyone. So the prototypes were sealed away and placed into a temperature-controlled storage facility. The engineers were reassigned to other projects. But then the world changed. In 2024, headlines began piling up with stories the electric vehicle industry did not want to hear. Repeated battery fires, overloaded power grids during summer, lithium mining scandals in Congo and Chile, and waves of consumer complaints about painfully long charging times during freezing winters. Range anxiety did not disappear, it only became more complicated and more frustrating. Honda saw the moment. In early 2025, Honda's leadership made the decision: revive Project HX Prime. They did not start from scratch. They opened the storage facility, took out 3 prototypes that had been sitting still for nearly 13 years, upgraded them with modern components, and put them back on test roads within 5 months. The results stunned even the engineers who had originally designed the system. At first, it may sound like a normal revival story, but it is the numbers from those tests that could change the entire game. The machine nobody believed was real until they saw it. So, what exactly is this engine? And why is it different from everything that has ever existed before? Let's begin with what it is not. This is not a normal hybrid car like the Toyota Camry hybrid or the Honda Accord hybrid that you already know. Those cars use an electric motor to assist the gasoline engine in city driving, and their batteries are charged through regenerative braking. Efficient, yes, but still dependent on gasoline, and still limited in obvious ways. This is also not a plug-in hybrid like the Chevy Volt or Toyota RAV4 Prime vehicles that need to be plugged in overnight to get the full benefit. What Honda has just demonstrated is described as a self-regenerating hybrid system, also called a closed-loop hybrid system. And that name is not accidental. At the center of the system is something engineers call a thermal regenerative piezoelectric drive. It sounds complicated, right? But the principle is not that hard to understand if you think about it this way. A normal gasoline engine is extremely inefficient in terms of energy use. Most of the energy from fuel, sometimes up to 60 to 70%, is lost as heat and friction. That is why your car's exhaust pipe gets hot. That is money and energy literally going up in smoke. Honda designed a system that can capture that lost energy and convert it into electricity in real time. Using a multi-phase energy converter and a dual thermal electric feedback system, the vehicle continuously harvests heat from the engine, mechanical vibration from movement, and pressure from the exhaust system, all of which are converted into electric current and stored in a supercapacitor array about the size of a lunchbox. No large lithium battery, no charging port, no need to connect to the power grid. The car runs on gasoline, but the hybrid system continuously regenerates and amplifies electrical power from what would normally be wasted. And the numbers from real-world testing? They are so impressive that they are hard to believe, but according to multiple independent sources, they have been verified. The vehicle accelerates from 0 to 60 miles per hour in 4.3 seconds faster than most current Honda models and on par with many mid-range electric vehicles. Top speed reaches 180 kilometers per hour. And what is especially notable is that there is no torque drop when climbing hills, a familiar weakness of many older generation hybrids. But the most shocking number is the driving range. 760 kilometers on a single tank of gasoline. No charging, no stopping to plug in. Just refuel in under 3 minutes exactly the way you already do with any normal car and keep going. Fuel consumption. Around 5 liters per 100 kilometers, with the hybrid electric system cutting fuel burned by more than 40% compared with an equivalent pure gasoline engine. No range anxiety. No dependence on the power grid. No need for lithium. And another important point that does not get mentioned enough. The car works perfectly at minus 22 degrees Celsius, a serious problem for today's lithium batteries, which can lose up to 40% of their performance in freezing winters in states like Minnesota, Michigan, or North Dakota. On top of that, reports from independent laboratories confirm near zero emissions, just water vapor and heat coming out of the exhaust pipe in cold conditions. No significant carbon dioxide, no nitrogen oxide, no soot. If these numbers are accurate, and there are many reasons to believe they are at least close, then Honda has solved 3 of the biggest problems of electric vehicles at the same time: range, charging time, and infrastructure cost. And the cost? The total cost of this engine system is estimated at around $1,320 less than 1/3 of the cost of a standard electric vehicle drivetrain. Operating cost? 0.8 cents per mile. For comparison, the average electric vehicle costs around 3.2 cents per mile, and a normal gasoline car costs even more. The break-even point for consumers? Around 1.4 years from the time of purchase until fuel savings are enough to offset the initial investment. This is not a small improvement. This is an economic breakdown of the entire auto industry. But no matter how good a technology is, it means nothing if it cannot be produced at scale, and this is where the story becomes much more complicated. The dark side nobody wants to talk about. Let's be honest, no technology is perfect, and if you only read the exciting headlines without looking at the real problems underneath, you will reach the wrong conclusions. The first challenge is production materials. Honda's engine system uses special corrosion-resistant alloys and customized piezoelectric materials called PTZO to generate electricity from mechanical vibration. These materials are not rare, but they are also not common in today's global automotive supply chain. According to estimates, initial production costs will be about 15% higher than a normal hybrid engine because a new supply chain has to be built. That is not an impossible problem to overcome, but it does mean production will not scale overnight. The second challenge is legal and regulatory. Honda filed a patent for this technology in Japan in 2023, then suddenly withdrew the application. Many legal experts speculate that this move was intentional, to protect trade secrets and prevent competitors from reading the detailed design in a public patent filing. But that also means Honda is now operating in a legally unclear zone when it comes to intellectual property ownership. The third challenge, and perhaps the most serious, is pressure from groups with conflicting interests. Information suggests that right after the leak, lobbyists in Brussels began pushing the European Commission to review hybrid performance standards and synthetic combustion classifications. In other words, they may try to redefine the rules so this new technology no longer qualifies as clean under European standards. In the United States, lobbying groups linked to the oil industry, surprised by a breakthrough that had nothing to do with drilling or pipelines, began calling the leak a PR stunt. Meanwhile, behind the scenes, some senators were reportedly drafting a bill to tax the thermal efficiency of non-standard propulsion systems. Basically, a tax on excessive efficiency. Read that again. A tax on a car because it uses too little fuel. If that does not show you how much interest is being threatened here, nothing will. The fourth challenge is intellectual property theft. When a group of engineers, reportedly former Honda subcontractors, posted technical diagrams of the system on a public whistleblower forum, the documents were downloaded more than 4 million times within hours. Research and development departments at Chinese automakers were reportedly already reviewing Honda's old hybrid documents from university libraries. Reverse engineering had begun. Japan's Ministry of Economy was reportedly warning that intellectual property theft was almost unavoidable. And this is exactly where the race becomes even more intense, because Honda is not the only one trying to dominate the future of car engines. Who is winning and who is losing? Let's look at the bigger picture of the competition unfolding right now. Tesla, the most iconic electric vehicle company in the world, reacted with a worrying silence. Elon Musk, who usually comments on everything from cryptocurrency to politics, did not post a single word about Honda's engine. Not one tweet, not one comment. And according to internal information, Cybertruck production line upgrades were paused for further review. That is not a sign of confidence. Rivian and Lucid, two of the brightest names in the electric vehicle startup wave, are in the most vulnerable position. Both are burning cash at an alarming pace while trying to scale production. A technology breakthrough that could redefine high-performance vehicles at a much lower cost would be a nightmare for their business models. GM and Ford are in a more complicated position. They have invested tens of billions of dollars into battery infrastructure and electric vehicle production, but at the same time, they still have deep experience with internal combustion engines. If self-regenerating hybrids become the new standard, they could pivot faster than pure electric vehicle companies. But the question is whether they are willing to walk away from electric vehicle investments that have not yet become profitable. Hyundai and Kia from South Korea are watching very closely. They have built one of the most competitive electric vehicle ecosystems in the world, but they also maintain strong hybrid capabilities. That could become their advantage. Japan, as a country, is in a favorable position. Toyota, Honda's historic rival, has long been a pioneer in hybrids with the Prius. If the world starts turning back toward hybrids as a practical middle ground solution, the entire Japanese auto industry could benefit. China, the country now dominating the global electric vehicle market with BYD and dozens of other EV brands, is facing a different strategic challenge. It has built a massive lithium battery supply chain and has bet on electric vehicles as a tool for industrial dominance in the 21st century. A hybrid revolution could significantly reduce that advantage. And American consumers? Especially middle-aged and older drivers? People who still remember when filling up with gasoline was normal and who worry about finding charging stations on long road trips, this may be the news they have been waiting for. A self-charging hybrid vehicle that needs no special infrastructure can travel nearly 800 kilometers on a single tank and can refuel in 3 minutes at any gas station across the United States? That is a value proposition most American drivers would find very hard to resist. So, in the end, the biggest question remains, is this technology truly powerful enough to change the future? What future is waiting for us? If Project HX Prime is really what the leaks suggest, and there is enough indirect evidence to believe at least its core is real, then the coming years may become one of the most turbulent periods in the history of the auto industry. Think about it in layers of impact. The first layer, consumers. If Honda launches this system in 2026 or 2027 at a competitive price, car buyers will have an option that has never existed before. Electric vehicle-like performance, superior range, lower operating cost, and the convenience of traditional gasoline cars. No major trade-off. That is an extremely powerful offer. Especially for American consumers in rural areas, in states with harsh winters, or simply people who do not want to change their refueling habits, this could be the car technology of the century for them. The second layer, the electric vehicle market. This does not mean electric vehicles will disappear, but it could significantly slow down the transition, especially in segments and markets where charging infrastructure is still weak. Tesla will still have a market, but it will have to compete with a new option that has very real practical advantages. The third layer, the global supply chain. If lithium battery demand drops even by 20 or 30% compared with current forecasts, that would be a major shock to lithium, cobalt, and nickel markets. Mines being developed in Chile, Argentina, and Australia would face serious questions about their future. Battery factories in Kansas, Georgia, and Nevada would have to reassess their expansion plans. The fourth layer, energy geopolitics. This is something few people mention, but it may be the most important. A car that creates electricity by burning gasoline extremely efficiently without depending on national electric infrastructure means no country can control it through the power grid. No one can shut off the source. No one can create dependency through control of a charging network. For the United States and for any country that wants to secure energy independence, this is a completely different story about sovereignty and resilience. The fifth layer, government reaction. This is the hardest variable to predict. Governments around the world have committed so strongly to the electric vehicle roadmap that changing direction now would be a politically expensive admission. There is a real chance we will see governments try to reshape regulations to protect investments they have already made, regardless of which technology is actually better for users and the environment. Honda is reportedly preparing to officially announce this technology at the upcoming Tokyo Auto Show, not as a concept car, but with a real production roadmap. The first models may launch in Asia and the Middle East first, where electric vehicle charging infrastructure is still weak and demand for practical solutions is very high. From there, if it succeeds, expansion into the American market would be the obvious next step. The target revealed in the internal roadmap, 1 million engines per year by 2027. If Honda can pull that off, this will not just be a story about a car. It will be a story about how one engineering decision made inside a sealed room in Japan could reshape the energy market, global geopolitics, and the daily lives of hundreds of millions of people around the world. Take a second and look back at everything we have just gone through. A 75-year-old automaker, not exactly the loudest name in the modern tech wave, may have just proven something many people thought was impossible. A car that creates electricity from its own operation without charging infrastructure, without a massive lithium battery, and without dependence on the national power grid. If this is real, and many signs suggest that at least the core of it has a real foundation, then the questions we have been asking for the past 10 years about the future of electric vehicles, clean energy roadmaps, and the global lithium supply chain all need to be asked again from the beginning. But here is the most important thing to remember. Nothing is certain yet. We have not seen a complete public independent test. We have not seen Honda officially confirm all the numbers mentioned. And the history of the auto industry is full of promised breakthroughs that quietly disappeared because of technical reasons, financial reasons, or pressure from powerful interests that felt threatened. But what is worth noticing is this. This time, the reactions from financial markets, from electric vehicle stocks plunging, to the Japanese yen rising, to Honda shares jumping nearly 20% in one trading session, do not look like reactions to an ordinary rumor. People managing billions of dollars do not behave like that just because of an unverified story. What happens over the next few years? That is the question. The auto industry, the energy market, and millions of consumers are all waiting to see answered. Can Honda mass produce this technology the way it has promised? Will governments and powerful interest groups try to block it? And is this the end of the rising electric vehicle era, or just a turning point that forces the industry to rethink the road ahead? What do you think? Do you believe a self-regenerating hybrid system like this is possible, or do you think this story is being overhyped? And if this technology is real, would you buy a car like this? Leave your answer in the comments below. We want to hear your opinion. If this video gave you a new perspective on the electric vehicle race, hit the like button to help this video reach more viewers. And if you want to keep following this story as more official information from Honda comes out in the coming weeks, subscribe to the channel now. This story is not over, and we will be here as it continues to unfold.